Hi everyone. So here is a simulation for the electrostatic lab, and so as I mentioned in the previous video for electrostatic interactions, I will be showing you the simulation outcome for these numbers that we had 4 microcoulomb and 8 microcoulomb at 2 centimeter distance. And once again, in the calculation I made, I have found 7.720. And now instead we have 7.19 10 to the 2, which is 719 instead of 720 because of the fact that the simulation is using the constant, electrostatic constant, Coulomb constant as 8.988 instead of 9. So that gives us this slight difference. So whenever the lab is asking you to do put these, specific values of the charges at specific distances, you just carry these numbers. You don't need to do any calculation. And when you need to do the calculation in that specific question, there's only one, I believe, you can use the K to be 9 times 10 to the 9 in that case. And I'm giving you a 5% error margin in the calculation questions anyway, so it should be fine. Here, instead of putting +4, I change it to -4 microcoulombs so that you can see the arrow changes. So let me change this to +4 so that you can see how the arrows are changing from. So in this case, because one is negative and one is positive, they're attracting each other. Therefore, the force that Q2 is applying on Q1 is toward right, and the force that Q1 is applying onto Q2 is attractive, so therefore it's toward left. So if you use positive instead of negative, you see that they're going to be repelling each other because they're both positive in this case, and like charges don't like each other and they repel each other. So Q1 applies the same force magnitude-wise. I didn't change anything other than changing the charge 1 being negative to positive. So the value-wise, the magnitude of the force didn't change. As you can see, it is still 719 Newton according to the simulation. So it's written in scientific notation form is 7.19 times 10 to the 2 Newton. And the direction of force is the only thing that changed. So Q1 is repelling Q2 by pushing it away from itself toward right, and Q2 is repelling Q1 by pushing it toward left. So these are the directions that you need to look and write in the laboratory activity. By questions are going to ask you the directions of the forces, so you're going to write either toward left, toward right, whatever you're seeing in these simulation arrows, basically. And let me change one thing is, like, as you can see, you need to make sure that this dashed line is along this exact mark. You can use like a paper or a ruler or something that to make sure, because you can actually move it slightly left, slightly right. Just make sure that they're on the spot that the mark is showing for the distances. So you can see as the charges taken away from each other, I didn't, touch any charge value. I just took Q1 away from Q2, and the value of the force decreased substantially, right? It was 7.19 and now it's 1.80. And so if you basically put it even closer, it's going to be greater. Now it's 10 to the 3. Look at the power of 10. So it's actually 14.7 10 to the 2. It's much bigger than 7.19, right? So with following the simulation, you can get familiar yourself with it, and you need to click on scientific notation, and we'll be using macroscale here. I believe the usage of the simulation is pretty easy, and I hope that it gives you the idea how charges interact and how the interaction changes when your charges get bigger or smaller, or the distance between them gets smaller or bigger. That basically is the aim of this activity you will be doing on the lab. And I hope it helps you to understand in general this concept of electrostatic interaction. So have a good day.